Good morning, grade 10s. I hope you guys are all doing well and that you're keeping up to date. Yay for Friday. The first thing you need to do, please, today is to download the memo for your homework from yesterday. So you will see on Teams, or your teacher will forward it to you. It says memo 7th of May 2020. Please mark your work, do your corrections. And then today we are moving on with Theorem 3. Right, so Theorem 3, please note that this is used when you are given a quadrilateral and you are asked to prove that the quadrilateral is a parallelogram. This proof needs to be learnt, so please do memorize it. And the theorem states that one pair of opposite sides of a quadrilateral are equal and parallel. It makes that quadrilateral a parallelogram. So basically, if you've got any four-sided figure that has got one pair of opposite sides which are equal in length and parallel, it means that that four-sided figure is a parallelogram. So you can see we are given quadrilateral ABCD. They tell us that AD is parallel to BC, and they tell us that the length of AD is equal to the length of BC. So what we are required to prove is that ABCD is a parallelogram. The first part of our proof is that we are going to construct diagonal AC. So you can see there in the drawing that AC has been constructed. And now we are going to look at two triangles individually. So triangle ABC and triangle CDA. And already you should start to see that we're going to be proving congruency. So the first thing, order doesn't matter, but the first thing that you can see, because AD is parallel to BC, it means that angle A1 is equal to angle C2. And that would be alternate angles. It forms the shape of a Z or an N. So it's your alternate angles. The second thing we can see is that line AC is common. So it's a common side for both triangles. And the third thing we can see is that AD is equal to BC. That was given. They told us that in the instructions. So that has given us enough information to prove that triangle ABC is congruent to triangle CDA. Our reason would be side included angle side. Now, because those two triangles are congruent, it means that all three angles of the one triangle are equal to the corresponding angles of the other triangle, and all three sides of the one triangle are equal to the corresponding sides of the other triangle. So therefore, we can see that angle A2 is equal to angle C1 because of our congruent triangles. Also, we can see that angle B is equal to angle D because of our congruent triangles. Now, if you look at angle A2 and angle C1, you can see that if you drawn in from BACD, it gives you alternate angles, and you've got the shape of your N, which means that AB must be parallel to CD. So because we've proven that our two triangles are congruent, we have proven that the other set of sides are parallel, which means now we have two pairs of opposite sides which are parallel, which proves that it is a parallelogram. So therefore, ABCD is a parallelogram. We've got opposite sides which are parallel. So from the fact that one pair of opposite sides were equal and parallel, we could prove that the other sides were also parallel, which therefore proves that it is a parallelogram. We're now going to do an example together. So if you have a look at the diagram, it says that ABCD is a parallelogram. They tell you that ED is equal to BF, and they have asked us to prove that BEDF is a parallelogram. So I'm going to switch over and I'm going to do this with you as an example. Okay, so we are starting off with our first example. First thing is they tell us that ADBC is a parallelogram. So because it's a parallelogram, we know that AD is parallel to BC. They also tell us that ED is equal in length to BF. And what they've asked us to prove is that BEDF is a parallelogram. So the first thing that we are going to do, you're obviously going to have your statement and reason. We can see that AD, we should know that AD is parallel to BC, and that's because they tell us that it is a parallelogram. So your opposite sides of parallelogram ABCD are parallel. So that's quite straightforward. The next thing that we can see, if this line is parallel and that line is parallel, do you agree with me that ED would be parallel to BF? And the reason is because it forms part of that straight line. The line hasn't curved or moved or anything, it's still a straight line. So therefore we can see that ED is parallel to BF, and your reason is that AED and BFC are straight lines. Okay, so we are already halfway there because we have proven that ED is parallel to BF. Now remember, the theorem that we're working with says that we can prove a parallelogram if we prove that one pair of opposite sides are equal in length and parallel. So we've already proven that they are parallel, and it just so happens that they've told us that ED is equal to BF. They've told us that they're equal in length. That's why we have these little indicators here. So that is given. So we have the two pieces of information that we need. Firstly being that these two lines are parallel to each other, and secondly that they are equal in length. So therefore we can prove that BEDF is a parallelogram, and our reason would be one pair of opposite sides are equal and parallel. Okay, so just to recap, we've proven that ED and BF are parallel. They have told us that ED and BF are equal in length. So one of our conditions to prove that a quadrilateral is a parallelogram, theorem 3, is that it has one pair of opposite sides which are both equal and parallel. So therefore BEDF is a parallelogram. Our second and last example that we're going to do for today actually comes from your textbook. So it's one of your homework questions which you are going to do together. You can see that you have got quadrilateral ABCD with a diagonal which splits up your diagram into two triangles. They tell you that triangle ABD and triangle BCD are two isosceles triangles. They tell you that BD is equal to BC, and they tell you that AD is equal to BD. They also tell you that angle C is 75 degrees, and they tell you that angle ADB is equal to 30 degrees. And they've asked us to prove that ABCD is a parallelogram. I'm going to switch over and we're going to do this video as an example together. Right, so in our second example, they tell us that we have ABCD, quadrilateral ABCD. They tell us that ABD and BCD are isosceles triangles, and what they want us to prove is that ABCD is a parallelogram. They give us a bit more information which I'm going to fill in now. So the first thing they tell us is that angle C is equal to 75 degrees. So I'm going to fill that in, 75 degrees. They also tell us that ADB is equal to 30 degrees. So ADB, that's this one, is equal to 30 degrees. they tell us that BD, so the diagonal, is equal to BC, which is our top line there. They also tell us that AD is equal to BD. So what you can see is that this top line, the diagonal, and the bottom line are all equal in length. Now, what you should also be noticing is that in this isosceles triangle, if that is 75 degrees, then what is D1 going to be? Also 75 degrees. If you look at this triangle here, another isosceles triangle, this over here is 30 degrees. So in order to work out the sides of angle A and angle B2, we're going to have to say 180 minus 30, and then the answer we would divide by 2 because they're equal. So I'm going to get into those now. So the first thing that I'm going to do is I'm just going to write down the sizes of all my angles. So we know that C is 75 degrees. We know that D1 is equal to 75 degrees, and it will be angles opposite equal sides. We can work out that B1 is equal to 180 minus 75 minus 75. So angle B1 is equal to 30 degrees. My reason would be interior angles of a triangle. So I'm going to fill that in there. B1 is 30 degrees. Okay, then if I look at this triangle here, I've got D2 is 30, and I know that those two, I'm going to say 180 minus, so B2 is equal to angle A, sorry, just angle A, and my reason for that would be angles opposite equal sides. I'm going to work out the size of them, so I'm going to say B2 is equal to A, which is equal to 180 minus 30 divided by 2. So the interior angle is 180 minus 30, and then I get my answer, and I'm dividing by 2 because these two are equal because of the isosceles triangle. So 180 minus 30 is 150. 150 is equal, 150 divided by 2 is 75. So angle B2 is equal to angle A, which is equal to 75 degrees. Okay, so, and my reason here would be interior angles of a triangle. So I'm going to fill in those angles now. So this is 75 and this is 75. Okay, so now actually getting back to proving that ABCD is a parallelogram, we know that we're working with Theorem 3, which says that a quadrilateral is a parallelogram if one pair of opposite sides are both equal and parallel. So you can see that we've already proven that BC is equal to AD. And that was given. They told us those three sides are equal. So the first thing I'm going to do is say BC is equal to AD. And my reason would be given. Okay, so that's the first thing, is that my opposite sides are equal. Okay, the second thing that I want to now prove is that my opposite sides are parallel. So if I have a look here, I'm just going to use a crayon so that you can see the shape formed. Now what do you notice about angle B1 and angle D2? Do you notice that B1 and D2 are both equal to 30 degrees? Now what you should know is they form the shape of a Z or an N, which makes them in the position of alternate angles. Now you should know that alternate angles are only equal if your sides are parallel. So you can see they are equal, which means our sides must be parallel. So I'm going to say there that angle B1 is equal to angle D2, which is equal to 30 degrees. Okay, so therefore BC is parallel to AD. My reason would be alternate angles, parallel sides. Okay, so we've proven that BC is parallel to AD. Okay, and then now what we've done is we've proven that they are equal in length, and we have proven that they are parallel, so that is enough to prove that ABCD is a parallelogram. So then you would then say therefore ABCD is a parallelogram. And it would be one, your reason would be one pair of opposite sides are both equal and parallel. Okay, so there's the whole screen with the whole example on it. Okay, grade 10s, that brings us to the end of our lesson. For homework, you are going to, from your textbook, do exercise 4 on page 196. You are going to do question 2 and 3. We've already done question 1 together, so you're just going to do question 2 and 3 on your own. Please, if you're stuck, ask your teacher to help you. They are more than happy to assist where they can. But that's all from me for today. I hope you guys have a great weekend. Stay safe and see you on Monday.